Hello, ladies and gentlemen. Today we're going to continue solving, but this time we're going to solve equations that already have the word log in them. So we're going to be solving logarithmic equations this time. So we're going to continue on in your notes. If you want to just add these after the examples we did yesterday, that would be wonderful. So just like exponential equations, there are two types of log equations. There are those that have logs written on both sides of the equal sign, and then there's those that have just the word log written on one side of the equal sign. Either way, we're going to set up some different things, and we're trying to solve for x, but whatever way they're set up is the way we kind of want to work with them, okay? So this is what we do when we have logs on both sides. So think about making things equal. We talked about this on our last video when we were solving exponential equations. We talked about making things equal. That's that property of equality there. So what if I have a log base 5 of something and it has to equal a log base 5 of something else? Well, it only makes sense that both of those things in the parentheses have to be the same. Log base 5 of something equals log base 5 of something else. These two things have to be the same in order for that to happen. So I just set the 4x minus 7 equal to the x plus 5, and then I can solve for x without worrying about the log base 5 business. So how would I solve this for x? Get x's together on one side. I'd have 3x minus 7 equals 5 here. Then I'd add 7. So I'd have 3x equals 12, and I'd get x equals 4. That means if I take this value 4 and I plug it in there and there, both sides should be the same thing. So on this side, I'd get log base 5 of 4 times 4 minus 7. And on the other side, I'd have log base 5 of 4 plus 5. And notice if we just calculate what's in those parentheses, 16 minus 7 is 9. This side is log base 5 of 9 equals log base 5 of, what's 4 plus 5? That's right, it's 9. So notice those two are in fact equal. It checks. That's what we're trying to do, is find that x value that makes it equal. Now let's look at what happens if we only have log on one side. For this, we're going to switch our gears a little bit. Just like we did yesterday when we had x's all by himself and we were trying to work on that, we're going to use inverse operations to try to get that x alone. When we get stuck, we're going to change it into exponential form to see what it looks like. So we need to remember what that log represents. So here we need to isolate the log and change it into exponent form. So that means I want to isolate this part and change it into exponential form. So see that 7 that's in front being added to log there? We need to undo that. We need to get rid of that. So I'm going to subtract 7. I'd have log base 10 of x equals 4 minus 7. That's negative 3. Now that I've done moving what I can here and done isolating, now I need to write what this means. Remember that every log represents an exponential equation as well here. So 10 is the base. 10 to what power? Negative 3 equals the x. So 10 to the negative 3 power, you can type that in. You can write it as a fraction if you want to, or a decimal. X would equal 0.001 or 1/1000th. So this is what x equals. Let's keep that same idea here when we go into this next one. We need to isolate the log as best we can. Here's the natural log. Okay, there he is. So let's isolate him. Let's add the 3. 2 natural log of x equals 8. There's a 2 still in front of that natural log. We're going to divide. We have the natural log of x equals 4. So we're trying to find out natural log of what number equals 4. Well, you're not going to know that in your head. Let's turn it into exponential form. Let's write what it means. Remember, natural logs have a little base of e down here that you don't see. So that means we're talking about e to the 4th power equals x. So what is that little e guy to the 4th power? Ask the calculator. E to the 4th is 54.6 roughly, and that would equal x. So there's my value. And another one, we're going to solve for x. So we need to isolate the log as best we can. And I'm looking at this log, and it doesn't appear that I need to do anything. Here, I don't have anything in front of the word log, nothing to add or subtract. I can't do this because they're surrounded with parentheses here. So now would be a good time to write what this means. This is a base of 2. To what power? That'd be over here. 2 to the 5th equals x minus 6. And now we go to our calculator and we type in what is 2 to the 5th? That should be 32 equals x minus 6. Add the 6 now. We get 38 equals x. So again, all about that idea of remembering what a log means. And last but not least, make sure you get this one in your notes. So we have a log base 4 of x plus a log base 4 of x plus 12, and it equals 3. Notice we still have logs on one side of the equal sign. So we have to do our best to isolate the log, and the problem is in this case we have log written in 2 places on the same side of the equal sign. So how in the world can we sort of condense this to make sense of what's happening so we can isolate it as best we can? Well, remember those rules for expanding and condensing? That's what needs to happen here. The properties of logs say when you are adding logs here in expanded form, we need to think about what this meant. When I wrote log something plus log something else, it meant I had a log of a product. So I need to write this as log base 4 of 2 things that were being multiplied. The 2 things were x times the x plus 12. Those product properties, or that property with logs is coming back here, okay? So we need to remember when it's expanded out how to condense. And then we can write the 3 on the other side. Notice by condensing, we're only writing the word log one time, but it's a log of all of that. So basically, we have the log of 4, and if I take the x times the x plus 12, I have x squared plus 12x. So now I have the log base 4 of this stuff equals 3. Again, there's nothing that I can move away here, but I should now rewrite what this means in exponential form. This means that I have a base of 4 written to the 3rd power, and it equals x squared plus 12x. So 4 to the 3rd power, if you remember, that is 64. So I have 64 equals x squared plus 12x. And you should be thinking what I'm thinking. Oh boy, there's an x squared in there, which means we have to factor to solve. So we're going to get 2 solutions here. Let's bring that 64 over to the other side. So we'd have 0 equals x squared plus 12x minus 64. And now you ask yourself, how do I factor this thing? AC method. What multiplies to make negative 64 and would add to make positive 12? Negative 64 and add to make positive 12. That's probably what you're thinking. Maybe it's negative 416. Were you thinking that? Probably, right? So that's the 2 numbers that we want to use when we stick them in the 4 squares here. X squared minus 4x, 16x minus 64. Factoring, don't forget how to do that. And now we write our 2 factors, x minus 4, x plus 16. We solve each one, x equals 4, x equals negative 16. Now notice we got 2 solutions here. And it does say make sure to check your solutions. This might be an instance when we got an extraneous solution that popped up right here. So we need to plug into the original equation to check them. So let's check the 4. We'd have log base 4 of 4 plus log base 4 of 4 plus 12 is 16 equals 3. Now you need to evaluate this in the calculator. Typing the log of 4 divided by the log of 4, that'd be 1. And if you evaluate this in your calculator, log of 16 divided by log of 4, that's 2. Does 1 plus 2 equal 3 like it's supposed to? Yes, it does. So the 4 is a good solution. I'm going to put another circle around him. We checked him. He works. Now let's go to that negative 16, doing the same thing. Log base 4 of negative 16 plus log base 4 of negative 16 plus 12 negative 4 equals 3. So now trying to evaluate this in my calculator, log negative 16 divided by log 4, guess what happens? You get a big ol' error. Can't do that, okay? Can't evaluate that. That's the one that's extraneous for us. So we don't want to list him as a solution. So make sure that you're checking those solutions when you get those two answers. That's a key idea. And you should check always anyway, just to be sure you're right. But that's especially when this comes up, okay? So thank you for taking good notes, and we'll continue on solving log equations.